distribute cold energy in the form of chill water to multiple buildings around KLCC. Then we also have done some of the petrochemicals projects, such as Mundara. And then in 2016, we also got another district cooling system, Cargo Education Hub, right, where it's a centralized chill water system, and then supplying chill water to multiple universities. And then in 2020, right, we also ventured into energy efficiency business. So for this energy efficiency business, the first two projects that we got is the hospital in up north, Penang, where we do chiller plant retrofitting, where we change the technology of the chiller plants and help them to improve the efficiency. And then in basically during COVID, when there's a boom in the semicon industry, we are back in the clean room business, where we did multiple big projects such as Neon in Hyderabad, Expert in Kuching, Terra, and also we ventured into data centers. So we did the phase 1 Microsoft data center in Jaya. Right, so in 2023, end of 2023, the company split off a new entity called IQ Energy Facility Management, where we only focus on HVAC and energy efficiency projects. So these are some of the summary of the company. The company has 450 employees. We have 7 offices globally, experience of 30 years, right? So completed 200 over projects. For clean room, we have built over 1 million square meters of clean room. And then these are revenue for the year for 2024, 2023, and 2022. So these are some of the standards licenses for us to operate. So in Malaysia, there are 3 entities under the IAQ group. First is the IAQ Solution, where we do the design and build for clean rooms and large-scale projects. We also have the energy engineering, project management and Gambahan, where we focus on project management. And lastly, we will only focus on IAQ EFM here, right? Like as I mentioned earlier, we focus on energy efficiency projects. So not only on HVAC, we do things like anything related to energy, even for steam and power. So 4 main businesses under the EFM group: energy management, district energy, cogeneration system, operation and maintenance. So these are some of our licenses. We are CIDB, G7 contractors, and we are also an ESCO company. So our key focus areas, so we basically focus in these 4 areas. The first is on energy efficiency improvement, right? And then reduction in carbon footprint, assist our customers to reduce capital and operational costs. And then on the operation and maintenance side, assist our customers to have efficient, stable, and continuous operation. Okay, next we go to the Malaysian National Energy Transformation Roadmap, or in short they call it NETA. Right, so what is this NETA all about? I think most of the participants here knows that now the world is moving towards carbon zero, right? So the main target is by 2050, we are going to have net zero carbon, right? So the action that we need to take now is basically to reduce the carbon emission. So there are a few things on the reduction in carbon emission. So for now, with the current technology, we are still focusing on carbon avoidance project, where we improve the efficiency, we reduce the carbon emission. Whereas in the future, the carbon removal projects will come in, right? So these are some of the roadmap on how we're going to achieve net zero. Okay, next, this is on the NETA. So actually, the government, which is headed by the Ministry of Economy, have identified 6 energy transition level: energy efficiency, renewable energy, hydrogen, bioenergy, green mobility, and carbon capture. Right? So for us, we will only focus on the energy efficiency side. Okay, so the targets for NETA, right? So on the energy efficiency side, the target is that by year 2040, they would like to have 11% carbon reduction, and in 2050, the reduction will be up to 23%. right? So this is on the industrial and commercial energy, whereas on the residential, 10% by year 2040 and 20% by year 2050. So the government has actually taken the initiative. So what they are going to do is they have committed a certain amount of budget to actually improve the efficiency of the government buildings. So you can see that the amount of funds that they are building, right? Like investment 2 billion in smart devices installation, 2 billion into retrofitting government buildings, and then by year 2040, they will increase it to 6 billion for smart device installation and 7 billion on retrofitting government buildings. And in 2050, 7 billion on smart devices. But actually, if you look at this, right, 2 plus 7 is only 9 billion. So actually, the 9 billion is not enough to improve or retrofit all the government buildings. So that is where actually the government also come up with this ESCO company, where the private sector will basically fund the retrofitting. Right, so I will explain in details later on all these zero capex model. Okay, so these are the key initiatives for energy efficiency. First initiative, right? The government will. I will focus on this highlighted in red because it will be more applicable to us. First is on the improve of energy efficiency awareness. So we designed the 5-star labeling standard to emphasize monetary savings in addition to technical energy savings, right? So if you can see, I think in the coming future, most of the commercial buildings, they will need to publish their energy energy usage in terms of star labeling, from 1 star to 5 star, right? And then enforce mandatory audits for large commercial and industrial building. Right, so they will implement the mandatory investment grade audit, focusing on high energy consuming commercial and industrial sector. Right, so I believe maybe most of you guys are affected by this. Maybe some of you have already received letters from ST stating that you guys will need to do energy audit. Next is establishing grid moving codes for energy intensity residential and commercial buildings. This will not affect the industrial side, but on the commercial side, they will basically need to calculate their energy usage in the form of building energy intensity level. Right, so they will need to calculate what is the consumption, kilowatt hour, in terms of the GFA. And the next thing is this establishment of ESCO platform. So as mentioned, so they are establishing this ESCO platform, right, that will coordinate public building retrofit with private ESCO. So for this, basically only companies that are registered under the Energy Commission and has been approved as ESCO company can do these projects. Right. Up to date, any questions on the meta? If not, then I will move on to EECA. Right. So for the Energy Efficiency and Conservation Act, so this is an act that has been people a lot have been talking about it since I think 2022. They have been anticipating for this act. So eventually in 2024 they have gazetted the act, right? So this act, the Energy Efficiency Act, right, actually replaced the the efficient management of electrical and energy regulation tools, which in short quite EMA, right? So basically this EMA is just a part of a regulation. So it is not as strong as an act. So that is why now they have come up with an act and they have a stricter enforcement. So the entities that are subjected to this EECA includes large energy consumer with annual energy consumption of 21,600 gigajoule or more. Previously, the reference is benchmarked against kilowatt hour. But when they talk in terms of kilowatt hour, right, they basically neglected the industrial side. When you guys use energy in terms of gigajoule, like steam, right? So previously, kilowatt hour is not a good benchmark anymore. So that is why now they have changed it to gigajoule, right? And then on buildings with gross floor area of 8,000 square meters and above, manufacturer and importer of energy using products. So now if you buy electrical products, let's say for your house or what, there will be 3 stars, 5 stars, right? So that will be labeled to all electrical appliances. And then there will be changes in the registered energy manager, registered energy auditor and accredited training institution. So previously, there is only one type of REM. So they call it REM, Registered Electrical Energy Manager, which will cover both electrical and thermal. So now they have split it into two, RAM 1 and RAM 2. So RAM 1 will only focus on electrical, whereas RAM 2 will take care of both electrical and thermal. So what is the responsibility of energy consumers? So for now, all the large energy consumers will need to appoint a registered energy manager, right? That will implement and monitor the energy management system. So previously, actually a lot of companies, they hire REM as part-time. So one REM could hold multiple portfolios. They help multiple companies to do registrations and submissions. For now, it will be more stringent, right? The government would like to make sure that when you hire a REM or a RAM to do the submission, the RAM will follow you, right? This guy is not doing a part-time, helping everybody to submit. So that will be the first changes. Then develop and implement an energy management system, right? So all the large energy consumers must develop their energy management system with a prescribed period and in accordance with the guidelines provided by the Commission, right? So with this energy management system, right, it's not only reporting how much energy you are using. You need to tell them what is your plan to reduce your energy consumption. Next is submit energy efficiency and conservation report, right? So the RAM must prepare the report detailing the energy consumption management system and proposed improvement. Conduct regular energy audit. So previously, the government actually provided grants for industrial up to 100,000 to do the energy audit, right? So that is a grant for you all to do the energy audit. I think from now on, the grant will be minimized so that you guys will need to fork out the money because it's really an act for you all to do it. So the carrot on the stick is no longer there, right? So if you don't comply with all this, the government will impose penalties. So failure to develop and implement an EMS will be fined not more than 50,000. Failure by energy consumer to submit energy efficiency and conservation report on time shall be fined not more than 50,000. Failure to appoint a REA, Registered Energy Auditor, for required audit shall be not more than 50,000, right? So previously, the REM are used to do energy audit. So now no longer REM can be doing such things. So now they need a registered energy auditor to do the work. Okay, next we move on to the HVAC efficiency benchmarking. Okay, first is about the HVAC system in Malaysia. So as we all know, I mean, to us, aircon is very important to Malaysians and also Asian countries because for us, our climate, we are located in the equatorial, so we use a lot of aircons, right? So these are some of the sample of the load proportioning based on different industries and the aircon usage. For commercial building, right, you can see 51% of the energy is used for air conditioning system, whereas the rest is for other facilities. And then on a sample for automotive manufacturing plant, the air conditioning system takes up about 36%, right, which is the second largest after the production equipment. And lastly is the plastic manufacturing. Aircon is on the third largest consumer, second to compressed air system. Right, so with this you can see the air conditioning either is the biggest, second or the third biggest. So if you manage to save the energy, or you manage to make your HVAC system efficient, there will be a substantial savings, monetary savings to your operational cost. So some of the benchmark. So typically for air conditioning system, right, we follow to ASHRAE standards, right? Based on the ASHRAE standards, this is the good is 0.7 kilowatt per RT to 0.85 kilowatt per RT. Fair 0.85 to 1 kilowatt per RT, right? So far in Malaysia, most of the plants maybe age 15 to 20 years. We are looking at 1 kilowatt per RT and above, right? So for this, ASHRAE also recommends to have retrofitting to improve this system, to bring it down to lower. Right, so now the current target, we are targeting around 0.65 to 0.75 kilowatt per RT. And then this is based on green RE. For green RE, this is more applicable to commercial buildings, right? Not so much on industrial because it's very hard for them to benchmark on the industrial side. So based on the different rating, I think now you guys are aware that there are a lot of all these bronze to platinum rating based on different accredited bodies. So this is from green RE, whereas for, let's say, if you want to look at gold, right, you are looking at 0.68 kilowatt per RT and below. Right, so the maximum you can go also is only 0.75 for a larger system. Okay. And this is also another standard, where this is a Malaysian standard MS 1525. But we seldom refer to this, mainly it's only on the ASHRAE and the green RE. But from here, you can see it's also in the range of 0.6 to 0.78 kilowatt per RT. For this 0.57, all these are basically focusing only on the chiller itself, excluding the auxiliary equipment. Right, so what are the main problems encountered by facilities in Malaysia based on our site survey? High electricity bill from inefficient cooling system. So this is something, a real problem. A lot of people may not realize it, but if you really check back on those buildings, commercial buildings, electricity bill, the main source of high electricity bill is from the HVAC system. Next is on overcooling in most commercial and retail mall result in high energy consumption. So in Malaysia, it's a bit funny. If you go to the offices, right, you will notice that a lot of the staff, right, start wearing jacket in the office. So that is because overcooling, right? There's no control on the cooling side. So some places will be extremely cold, some places will be warm, right? So they just blast the aircon. So with all this cooling, it's basically burning your money. And then aging of chiller plants due to insufficient budget for upgrading. Another concept of aircon is unlike your process, because your process direct affect your production. But for aircon, as long as it's cold, then we run, right? So whether it is efficient or not, it doesn't matter. As long as it's cold, we are okay, there's no complaint. But aircon shouldn't be cold, it should be comfortable. Then operational disruption from outdated system and poor maintenance. Rising carbon emission, actually putting all these facilities at risk for non-compliance. So with the new government act, so all this inefficient system will be a risk for the owner on the penalty side. Okay, so now I will share some of the strategy to improve HVAC system. So for this HVAC energy optimization, so basically there are three types of investment that we have split into: low, medium, and high, right? So for the low investment, it is basically not much of changing of equipment, right? So, but the savings also will be less, between 3 to 10%. So one of the things is basically fine-tuning of cooling requirement, right? Aligning the cooling supply with natural demand. So as I have mentioned earlier, people wearing jacket in the office is not the right thing, right? So first is the adjustment of set point. So what the facility manager or owner can do is increase the chill water supply temperature, right, to reduce the power consumption, right? So a lot of time, once the design is out, okay, let's say we supply 7 degrees of chill water or 5 degrees of chill water. So basically, the facility teams will not change the set point. They continue to operate even though it is cold at the space area. Right? So, but if you were to increase the chill water supply, actually the power saving is substantial. So there's a rule of thumb. Every 1 degree increase in chill water, right, you actually save 3% of your chiller electricity consumption. And chiller consume the most in the chill water system. Okay, next is on zoning and scheduling. So dividing buildings into separate areas based on usage and occupancy, right? So, you know, in KL downtown, there are multiple offices. Actually, the offices in KL is oversupplied. So there are some areas that are vacant, but you still supply aircons to them because there's no controls. So there are things like dampers and all, control dampers that you can install to prevent all this overcooling. And then review of thermal load, right? So identify and mitigate internal heat sources such as lighting and equipment to prevent unnecessary cooling demand. Okay. Revise operating hours. So on this revised operating hours, actually a lot of operators also they are doing that. So for example, shopping mall or office building, right? You start work at, people coming into the office at, let's say 8 to 5, right? Your aircon, basically you can start switching it off, maybe at 4:34, then you save 1 hour a day. Or you switch on your aircon a bit later, right? So it's just purely about changing your aircon operating hours. From there you are getting your savings rate. Right? So these are some of the zero cost energy optimization strategy. Next is on low cost, replacement, repair of faulty instruments. Right? Things like repairing your valve, damper leakages, prevent loss of chill water, right? And also supply air temperature due to mixing. So a lot of times the air conditioning side on the maintenance side, right? So like what I said, as long as the aircon is cold, then we proceed, right? So things about like repairing all these things may be neglected. So by repairing all this, you can basically save some costs. Calibrate your sensors. So basically the sensors are your eyes and ears on the field, right? So giving the accurate readings to the control system actually helps to operate the system better, right? Then refurbishment of insulation to reduce thermal losses. Next will be on the medium investment, right? So on medium investment, it involves incorporation of some new technology and also parts replacement, right? The first part will be implementation of variable speed drive. So the variable speed drive allows the equipment to adjust its operating speed based on real-time demand. Okay, so traditionally the fixed speed, basically at whatever load that you will need, they will still running at full load 50 Hertz, right? So they are unable to throttle the motor speed, which leads to waste of energy. And then VSD also modulate the output to match the actual cooling and airflow required. So this actually helps to significantly reduce the power consumption. And for VSD, the speed to the power consumption is in the factor of cube. So whatever you save is in the cubes. So when you throttle even 1 or 2 Hertz or 5%, it actually brings significant savings. Right, so application in HVAC, right? What we can incorporate the VSD on, AHU supply fans, right? So in most of the cases, the AHU are neglected. So they just run fixed speed, they just supply the air. But with the VSD, we will be able to throttle the air supply to whatever is required. And then on the pumps, right, modulate water flow based on the cooling demands and cooling tower fans. So with the VSD, it basically helps to meet the actual demand. Because in a lot of cases during the design stage, right, we will design the equipment to meet the peak of peak. But the peak will only happen maybe 1 or 2% during the year. Most of the time it is operating at part load. So with this VSD, we can basically throttle the speed until it gives the actual required cooling. Then incorporation of machine learning software, right? So this machine learning software actually is software with the capability to use historical and real-time data, right? And they use this data to predict, adapt, and optimize the HVAC operation, right? But such incorporation can only be done with a system with a fully functional BMS. So this machine learning software is something new, right? The glamour name is, they call it AI software, but basically it's just machine learning. Okay? So what it does is basically it keeps changing your set point. It is a dynamic set point optimization. Because as you know, during the day, right, your cooling load demand will not be the same. But all your equipments are operating at the same speed. So with this, as they sense the changes in the temperature, so they basically change the set point, and this will help you to reduce the cooling load supply. And predictive cooling load, so it can also predict cooling load, right, and forecast the cooling demand based on weather, occupancy, and past trend preventing overcooling. And then this part is the high investment. So for the high investment, obviously when you invest at kind of capex, you will expect to have more savings. So the savings can go up to 40%, depending on the benchmark. What is the current efficiency of the system, right? So let's say, like what I showed earlier, the X-ray side, let's say the plant is operating at, some plants are operating at 1.2 to 1.3 kilowatt per RT. And if we can bring it down to 0.7 kilowatt per RT, we are looking at 40% savings. So what needs to be done? The first thing is to upgrade the chill water system, right? So we change the equipment technology, right, and aligning to actual cooling demand. So what is the change of chiller technology? With the new technology, actually VSD play a big role in the new technology. Previously everything is constant speed. So now we have this VSD screw chiller, magnetic bearing chiller, series counterflow chiller, and absorption chiller, right? So this VSD screw chiller and magnetic bearing chiller work best at part load, right? So if you install this and you install it to 100%, as long as you are operating anything less than 100%, the efficiency is very good, right? And then upgrading of cooling tower equipment, right? So on the cooling tower side, so cooling tower actually is considered one of the cheaper equipment in the chill water system, right? So if you really want to improve the efficiency of your chill water system, oversize your cooling tower, right? Because as long as your heat rejection is efficient, right, your chiller will be able to operate efficiently. And then obviously the changing of motors to IE3 motors. Now we are talking about high efficiency IE3. Some are even talking about permanent magnet, but the permanent magnet is not applicable to cooling tower yet. So we are still using IE3 motors, and also there are some new fans where they incorporate EC plug fan instead of the traditional axial fan. Then incorporation of various speed drive onto the pumps, right? And then this actually is on the water side. Why we focus so much on the water side? Because actually the water side consumes the most power. The next is on the air side. So on the air side now, the few simple technology upgrade will be upgrading the conventional fan to EC plug fan and high efficiency axial fan that comes with VSD. Actually, the main thing is the VSD that allows the throttling, right? The fan efficiency, right, improved by maybe few percent, but throttling the speeds will help you to save a lot, right? And there are also fans that use E5 motor, permanent magnet motors, right? And then implementation of chiller plant optimization system. So in the general HVAC system, right, one of the main things that are neglected is actually the control system. To me, the control system is the brain of the system, which is whatever high technology that you put, if there's no brain to control your system, right, your system will not be efficient. So implementation of chiller plant optimization is very important. In Singapore, actually, the government enforced all HVAC system, right, is equipped with BMS system. But for us, we have a BMS system, but normally when we see is normally it's not maintained, it's not really operating, or the operator may not know how to operate it. Okay. Next, we will go to the zero capex financing model and the case study. Are there any questions on the type of strategy for energy improvement? Okay, if not, then we move on to the zero capex financing model, right, and the case study. So what is this zero capex financial model? Okay, so this is the first one, the energy performance contracting business model, right? How this system works is basically for us, ESCO company, right? We will basically offer our customers zero capex upgrading. So we will come to your facilities, we will study the system, right? Propose the modification work. So once the modification is done, you can see like we will benchmark it with before your modification. Let's say you consume 100%. So during the EPC, we managed to bring the energy cost by 40%. So basically you save 40% of energy cost. So because for the ESCO company to come up with the investment, right? So we will need to return, need to have some returns. So for this, we will recover our capex by sharing the savings with our customers, right? So during the EPC stage, the customers may not get the full savings because it is shared between the ESCO company and the customers, right? But after the EPC contract ends, the owner will be able to enjoy 100% of the savings, right? So with this model, basically you can see is that the customer are not required to come up with any capex for their upgrading, and they will be getting their savings from their savings from the amount that they have set they have saved in the operation. So this is risk-free to the customers. So what if the savings is less? So if the saving is less, right, to customer there will still be savings, but the risk is all on the ESCO side. Right? So typically this kind of contract will be around 5 to 7 years. What are the benefits of this EPC model, right? First is zero capex investment. So basically it allows the owner to upgrade their system without forking any capital costs, and it reduces risk, right? Like what I said, the savings, the payment are all based on actual savings. The less savings it is, so the less payment you are paying to the ESCO company. And zero investment upgrade, right? All upgrading work shall be transferred to the client at the end of the contract. So depending on the contract period, right, it wouldn't be too long for EPC, right? And then reduction in carbon footprint, and then compliance with the regulation.
Normally, ESCO take how long time for the baseline?
The baseline, normally what we will do is we will go down to the site and install our loggers. So maybe a month to 2. 1 month will be enough. It depends on the application, right? So for applications that are quite constant, then 1 month will be sufficient. Because Malaysia weather is quite constant, so 1 month will do. Okay, so how these things works, right? First, we will basically examine your existing HVAC infrastructure, right? Then, basically we will go there and do some auditing also lah. So we will know what is your current baseline. Then from there, we will come up with the design, optimization planning. So once we have come up with the design, we will do the financial analysis, right, and discuss with the customers. So once we discuss with the customers, you are agreeing to the savings, and then also the shared percentage, then we can proceed, then we will do with the implementation. Right? Once it is implemented, then both of us will basically enjoy the savings. Right? So until the contract completion. So this is our first energy performance contract thing. This is for the KLCC district cooling system, right? So basically there is oversizing of the pumps. So the pumps is operating at an inefficient manner, right? So we basically went in and invested to optimize the pump, right? So each pump we managed to save the kilowatt from 430 kilowatt to 380 over kilowatt, right? So there's a 50 kilowatt savings, and they are around 8 pumps, right? So after we have done that, right? So the plant start in operation and we are getting the savings. So on our side, so this is some saving structures as sample. It's not a detailed one, right? Like year 0 to year 5. On our side, we take 70 to 85% of the savings, whereas our customers only take 15 to 30. The reason being, the first few years is heavily skewed towards us is because we have invested the money. We need to recover back our capex, right? That is why the first 5 years heavily on IEQ side, and then in year 6 and year 8 you can see it's more balanced. And then year 9 to year 10, right, the customer actually enjoy more savings. And after year 10, basically, we will be enjoying these savings perpetually. Right, so our 10 years contract, right, this is our 4th year. So during the studies, we were estimating 17% savings. But in actual fact, we are saving 21.5%.
Within the 10 years, so employers go maintain the equipment?
No, for this, we didn't maintain the equipment. We didn't retrofit the pumps, right? We did the modification to the pumps. Yeah. So there is no equipment change. So no change. We were not involved in maintenance. In some cases, right, we may need to maintain the system because in order for us to guarantee the performance, right, we need to make sure that it is properly maintained. So it is a very flexible kind of business model. Not necessarily you need to maintain it, right? Next is the cooling as a service or build, operate, transfer model. So what is this cooling as a service model? So for this cooling as a service model, it works differently, right? The work is the concept is that we will sell the cooling energy to you as utility. Just like you buying from TNB, now you are buying chill water from us, right? So what we do is basically we supply you the chill water and you will be paying us the chill water tariff, right? So what we will do, we basically will finance and rehabilitate or construct a new chiller plant, and then we will operate and maintain the chiller plant over the contract period. I think this is quite similar. This model has been used in a lot of different industries, not only chill water. I think some companies also buying steam from a third party, right? It is the same concept, right? So what is the benefit? The benefit is similar to the EPC, right? Zero capex. But the benefit of this is if you start early, right? Let's say you wanted to build a new plant or a new development where you need to fork out a certain amount for the aircon system, HVAC system. So we can come in early, so you totally ignore the cost on your side. So you can keep the money and put it into your core business. And then we will invest for you. Right, that is at the beginning stage, right? So it is also an asset-light strategy, right? So you transfer your fixed cost to variable costs to enhance agility, improve the cash flow, right? Because for this, why we say improve the cash flow? Because we sell to you at a fixed tariff, unless there's changes in electricity tariff, else the tariff is the same. So once if you can predict your usage, so basically it is a very fixed cash flow prediction. Then reduction in carbon footprint and compliance with regulations. So the concept is very similar to EPC, right? System assessment, upgrade planning, construction phase, operation maintenance, operational management, and system asset transfer. I would like to highlight on this, right? Why did we highlight in red service level agreement? Because the thing is that when we operate this plant, right? And we are selling you the utilities. Whether the plant is efficient or not, it is doesn't matter to your side because you are buying it at a fixed rate, right? So if the plant is inefficient, basically we are losing money. If our cost of generation is higher than what we are selling, right? So to you guys are buying at a agreed level. Whereas plant owner may suffer from high cost of generation as the years goes by. As the system becomes less efficient, your cost of generation increase. But for this, it's a fixed cost. Right? So this is a case study for a shopping mall. So it has a 2,500 RT. Right? So in 2018, the chiller plant was refurbished based on cooling as a service business model. So replaced 2 units of 1,000 RT chiller with its cooling towers, pumps, and electrical panel. And during this period, this is a 15 years contract. The operation and maintenance also is covered. So basically, the owner do not need to worry about the HVAC system at all. Anything happens, just call, and the company will be responsible. Right. So for this, you can see during the existing system, they are basically forking out 4.3 million in terms of OPEX, electricity, water, and O&M. 4.3 million annually. And then coming to the cooling as a service agreement, what they are paying is 4.2 million, right? So they basically save 151,000 a year, 3% savings. This may not be a lot to the customer sides, but one thing, the capex to upgrade the system has been covered under the cooling as a service agreement. So the customers basically get a new system, savings of 3% without coming out with a single cent, right? So that is the beauty of the cooling as a service model. And after 10 years, right, the system will be transferred to the customers and they enjoy 14% savings. Next, this is also another one for a commercial building, right? So for this building, it is a small system, and due to the space constraint, they are using air-cooled chiller. So the air-cooled chiller is one of the less efficient system, right? So what we propose is changing the chiller from air-cooled to hybrid chiller, right? Evaporative chiller. So from there, you can see under the business as usual, right? Their annual let's say their life cycle cost for 10 years, we calculate based on life cycle cost, is 7.54 million, covering the electricity and the operation and maintenance cost. So when we go in with the zero capex, right, we are able to bring the cost down to 7.265 system. 7.265 million, right? So there are savings and they did not fork out any money for the upgrading. The case study number 3, this is on a larger scale system, build, operate, transfer. This is a district cooling plant, right, located in Bago. So 7,500 RT. So this plant actually belongs to the Ministry of Higher Education, right? So they were developing this area. So we were there as the contractor and also the concessionaire holder for a short period of time. So the concession period is 20 years, right? So it involved building of the plants and also the chill water piping and also the operation and maintenance. So this is the study that we did for the government, right? Even the government would not want to fork out the capex. So the project is 65 million, right? So for this model, right, the capital investment will be forked out by us, 65 million, right? If the government were to do it themselves, they will have to pay 55 million, right? Why our cost is higher is because we need to build the network piping. Whereas for them, they just need to build 5 chiller plants. What we are building is one single chiller plant with the network to supply to 5 places, right? So you can see, in terms of capex, this may be higher, but in terms of OPEX, due to the high efficiency system, you can see there are substantial savings, almost 20%. And then in terms of operation and maintenance, we can save also almost 40%. Why the operation and maintenance is so much more cheaper is because when you need to maintain 5 sites, you have 5 teams of O&M personnel. Whereas for us, one single plant, right, we may have more personnel, but it's definitely less than 5 plants, right? So you can see from the total annual expenditure, right, for this cooling as a service is only 17.5 million, whereas this is 19.7 million. Annual savings is 2 million, right, which is 11%. So if the government were to calculate the payback, right, whether they pay us and all, the payback actually for the district cooling system is actually very fast. It's less than 5 years. Okay, so the summary. HVAC system are among the largest energy consumer in Malaysian buildings, right? So especially they are in equatorial climates. So it is very important for you all to ensure that the HVAC system is operating in an efficient manner. Next is on the government policy, NECTA and EECA 2024, right? Driving mandatory energy audits and efficiency improvement. Right, so now I believe we are still in a transition period. There are still some grants, there are still some benefits to the facilities owner. But eventually this will be over and everybody will be forced to be efficient. Right, so facilities, you guys should start benchmarking your HVAC system, right? Either using ASHRAE, Green RE, MS1525 standard to help identify your existing performance and what will be the retrofit opportunities. And then energy optimization strategy varies from low to high. So basically, maybe for you all can start with something low just to kickstart the energy efficiency journey. Low investment don't cost much, right? But you can basically help you to save some amount. So, and there are some available zero capex financing model, EPC, cooling as a service, build, operate, transfer that enables upgrade without upfront cost, right? So this slide was added at the end because based on the crowd, we think that okay, maybe you guys are more interested in what can the steam do, you know? So cogeneration district cooling system, right? So for IAQ, beside the HVAC system, we also do combined heat and power. Right, so as combined heat and power, we normally do EPC, we are EPCC, we are the EPCC contractors, right? So now about this HVAC system where we can get free chill water. So how it works? So this is what we call the cogen district cooling system, right? So the cogen side, definition of cogen, basically you are generating dual source of energy using one single fuel source, right? So from here, you can generate power, you can generate steam, right? The steam can be used for your process, or the steam can be used for the steam absorption chiller to generate chill water, okay? So primary fuel efficiency is higher compared to conventional generation. What we are talking about conventional generation is that you import from DNE and you have your own boiler, right? So cogen is definitely more efficient. So these are some of the experience of the team member. So from our team, we have done this district cooling system in Malaysia and internationally, right? We have done a few landmark projects like KR118, KIA2, KRCC. Those are some of the project references that we have, right? And internationally, we have done projects in Thailand, Dubai, right? And for cogeneration system, right, we serve, the team serve the customers like Petronas, GSPP, Dore, right? Okay, so let's talk about this cogeneration system on that, right? There are few types of drivers, right, for the generation of power. So the first one will be basically the gas turbine, right? Then second will be the thermal generation. Here is the heat recovery steam generator, right? So first the natural gas are injected to the gas turbine to drive it to generate electricity. The waste heat from the gas turbine is used to heat up the boiler feed water to generate steam via the heat recovery steam generator, right? And then with the steam can be channeled to steam absorption chiller, where they will generate chill water. So in conventional chiller, electricity is the driver, but for this steam is the driver, right? So this is the conventional design with a HRG generating steam. Second will be basically using gas turbine, and we utilize its exhaust gas directly into direct exhaust absorption chiller, right? So the flue gas will pass through the absorption chiller to generate chill water. Then lastly will be the gas engine. So gas engine can be used to generate the power, right? And then for gas engine, we will recover two types of energy. One is the exhaust gas, secondly is the hot water, the jacket water. So using this, we will generate to the multi-energy absorption chiller to generate chill water, right? So for this system, it actually depends on the requirement of a facility, right? So if your facility is thermal driven, which means you may need more steam or you may need more chill water, then the gas turbine will be a better option, right? Because the efficiency of gas turbine is low for generation of power, right? But if you are power driven, then gas engine will be a better choice because the efficiency to generate power using a gas engine is way higher, 30% higher than gas turbine. Right? The efficiency of gas turbine is in the range of 30 to 40 depending on your size. Whereas the gas engine efficiency is around 41%. Right? So when you have more power means you get less heat. Right? So these are some illustration on how you can generate the chill water. Right? Fuel gas going through the gas turbine HRSG, then using steam, and then to generate the chill water. Right, so this is a comparison. This is for a smaller machine, right? GPP 180D. This is around 16 megawatt of power, right? So this is a comparison: the whole generation system versus the conventional system. So as I mentioned, for conventional system, you are importing from TNB. For chill water generation, you are using electrical chiller, or if you need steam, you are using boiler. Whereas for us, it's basically injecting fuel to the gas turbine HRSG and steam absorption chiller, right? So you can see from here, the primary fuel efficiency is 72.44%, whereas for here it's 98.6%. So you can see the efficiency improvement in terms of fuel, right? It's 26%. Second, direct exhaust chiller, right? So that's what I explained earlier. The flue gas from the gas turbine is injected to the direct exhaust chiller, absorption chiller. Right, so you can see the efficiency difference, 71.6% versus 92.6%. Right, you can see a savings of 22% in terms of fuel. And next, this is the gas engine with a multi-energy chiller, right? So same concept, driver is gas engine, extracting the jacket water and the exhaust gas, right? So the efficiency 45% versus 74.72%, right? So if you can see on the top here, heat to power ratio, that is what I was explaining about what type of system you need. Heat to power means in this context, it's basically the amount of chill water energy to the power ratio. So you can see here the chill water energy is much more less than the power, right? So if your facilities is power driven, this is the system that you need to go for. If your facility is thermal energy driven, right, then gas turbine may be a better option. Right, so for critical facilities, so this is something that we are looking at if your facilities have don't allow any downtime, right? So there are things like gas turbine with the HRSG to generate the steam, right? And then you have a backup system for the boiler. So in the event if there's any breakdown on the HRSG or gas turbine, you will still be able to generate the steam required to power the steam absorption chiller. And we also have thermal energy storage tank. So this thermal energy storage tank actually acts like a battery, right? It stores thermal energy in the form of chill water when you don't need it, and when you need it, it will be discharged. So what are the benefits of this system, right? So improve energy utilization efficiency, reduce power grid transmission losses, right? Because the on-site cogeneration system avoid transmission losses. It improves economic growth. I mean, basically, it helps to create high-skill, high-income engineering and technical jobs, create new business opportunity in energy supplies, and right? Improve business competitiveness. Basically, you improve your cost efficiency, right? Improve power grid infrastructure, improve environmental, right? Lower emission of greenhouse, benefit to end users. Cogen has a much higher efficiency compared to separate generation of power and thermal energy, right? Improve efficiency actually lowers your production cost. Improve security of power supply. So in a lot of facilities, right? So if there are issues on the power supplies, maybe cogeneration system will help you to improve your power security. right? And then for the cogen system, normally the cogen system will be the primary system. The TMB will be used as a backup, right? And then reduce environmental impact through lower greenhouse gas emission. Okay, so I guess that is all on our side, right? So if there's any questions, we can discuss later or even now if you have any. Right? If you have any inquiry, you can just contact us. Okay, thank you.